My name is Philip McMullen, and I am the director of the MASS programs. And I'm joined with my team, several faculty members, a lot of folks here to speak with you this evening. So a little bit about our agenda. So I'm going to give a little bit of overview of the program, sort of high level application process, requirements, scheduling, etc. I'm joined by my whole team who are here on the call and will be available later to talk. Then we will cover first the architecture-based enterprise systems engineering program, the wireless embedded systems, data science and engineering, cover next steps, and then we will have breakout rooms by program. In the interest of time, what we're planning to do is to keep the program muted, and I would ask that you hold your questions till the end when we're in the breakout rooms, just so that we can make sure we get through all this material. We will be recording this session and making it available on our YouTube channel within a few days. So let's get going. So we are part of Jacobs School of Engineering. We are the largest in California among the public universities, and we are the 9th top engineering school in the nation. We have very distinguished faculty, over 230 research active faculty that if you enjoy our programs, will be able to interact with many of them. And we're very much committed to serving the needs of industry for latest research and education. So engineering has 6 departments: computer science, nano engineering, electrical engineering, structural, bioengineering, and mechanical engineering. All of our programs in the MASS program interact with multiple of these departments, which is one of the unique things about our program. So, Master of Advanced Study. Some people ask, what is an MAS? I'm not familiar with that. I've heard that before. Still a little background about the program. So it was started by the UC Systems back in 2001, sort of as a sister degree, if you will, to the traditional MS degree. They're taught by the same research active faculty with the same academic rigor. Basically, UC realized that, not everyone who wants to get a master's degree wants to go the traditional route, which often means having to quit a job, take out student loans, and be a full-time student. But people still wanted to get a master's degree, and so these MS degrees were created, and there's some unique characteristics about the MS degrees. One is the delivery and the timing allows for working professionals to keep their full-time jobs while pursuing a master's at the same time. With a traditional master's degree, typically classes are Mondays through Thursdays, and it would be very difficult for a professional to be able to do that and keep their full-time job. There's a very strong emphasis on practical application of the knowledge along with the theory. All of our MAS degrees have a capstone project instead of a thesis, and this capstone is a critical part of the learning and allows students to apply knowledge to real-world applications. They are interdisciplinary, so faculty teach from different departments. They have smaller class sizes, which allows a better ratio of student to faculty and TA support. And it's assumed that this will be a terminal degree, meaning that students, majority of students will not plan on pursuing additional educational degrees. If that is something that is on your mind, please stop and talk to me after the session, and I can give you some more information on that topic. But bottom line, at the end of the day or at the end of the program, you will have an incredible master's degree from the Jacobs School of Engineering, one of the top engineering schools in the country. So that's what you will have out of this program. So we've been around for 10 years, and there are well over, I stopped adding companies to the list because it won't fit on a page, but there are over 200 companies that have sponsored and had students participate in these MASS programs over the years. So general guidelines about program requirements. Again, these are general. There can always be an exception. So if you see something, you think, oh, that rules me out, talk to us. But generally, program requirements. For the AESE program, generally, the admissions committee are looking for individuals with at least 5 years of relevant professional experience. For the wireless embedded systems and the data science, faculty directors typically are looking for 2 years of relevant professional experience. The application deadlines on May 5th, there's an early consideration. What that means is individuals who have a fully completed application, references, transcripts, the whole thing, the subcommittee of the admissions committee will look at those applications and give individuals feedback as to whether or not they look like they would be a typical candidate for admissions to the program. There are cases where very strong applicants are submitted to the full admissions committee and may get early admission, but basically every completed application by May 5th will get initial consideration. The final deadline is July 7th. That's when the application system will close. All applications will be reviewed at that point by the full admissions committee, and final decisions will go out typically about 4 weeks after that time. All the programs generally are looking for bachelor's degree in engineering, science, mathematics, or physics, something that's very quantitative oriented. Again, those are general guidelines, and we've had some exceptions, and often the exception is going to be based on what the professional experience is and how that relates. We do not require a GRE, 3.0 minimum GPA. That is a UCSD requirement. But again, if your GPA is less, it depends on your application, but it is possible that you could be admitted into the program depending on the whole package. We do not require TOEFL if you've been working in the US for more than a year. And then there is a $120 application fee. A note, veterans can request a fee waiver for that application fee. You need to ask for that before, and there's information, reach out to us if you want information. You need to apply for that before you apply. You can't get a refund, you get a waiver before you apply, just FYI. Program schedule. So this is a little complicated, a lot of information on this page. So generally, all of the MAS programs are delivered in a similar style that allows for working professionals. So generally, classes are all day, Friday and Saturday, every other week of the quarter. UCSD is on quarters. Some of you may come schools, we're on semesters, we're on quarters. So classes are on Friday and Saturday, every other week. The exception from that is the AESE program. In addition to those Friday and Saturday every other week, 1 week per quarter, there is a 4-day class, all-day class session on that 1 week of each quarter. All classes are video recorded and available to students within a few days after the class. In case you have business travel, something comes up that you know it's going to make you miss a class, all classes are recorded and available for students to review. So the AESE program is the programs that, where this gets confusing potentially, is the AESE program is, by the university's view, a full-time program. It's delivered in a manner that allows us to satisfy the requirements for full-time and delivered in 1 full calendar year over 4 quarters, but it is still delivered in a part-time method, meaning as a student, you still keep your full-time job to pursue the program. The wireless embedded systems and the data science are both part-time programs and happen over 2 years. The West program is on one class day for the second year. The DSE program basically is 2 classes per quarter, but no summer class. The units noted in orange are capstones that are coming at the end. A note that because the West and the DSE programs are part-time only, they cannot sponsor international students who would require the university to sponsor the student. If an individual is already working in the US and has sponsorship from their company, you're certainly welcome to participate in either programs. Only the AESE program that's considered full-time would be able to sponsor an international student if that applied to you. General, we're very transparent as we think it's important for you to understand the cost of the program. So the ASE program, the West and the DSE costs are noted there. What's included in that is truly all-inclusive. It is your tuition, it is your books, it's software, it's parking on campus for campus days, and mandatory UC graduation graduate student fees. It does not cover mandatory health coverage, but you can waive that if you show that you have health coverage through another entity or concern. So if you go and look at other graduate programs, it is a scavenger hunt to figure out how much those programs cost, because tuition is one place and books are listed elsewhere. But this is truly an all-inclusive cost for our programs to enroll in the programs. I realize we don't have on there is that we also provide meals, breakfast and lunch on class days, so that you can focus on being a student when you're here on campus. So we have a lot of information on our webpage. So each of the programs has unique information with details about that program, overview. It has a course calendar for that specific program, information about the faculty who teach in the program, more information on the curriculum in that program, classes, what's covered in the classes, admissions specific information. It's a little bit different for each of the programs. Information about the cost, what's included in them, and then resources, which includes an FAQ. So a lot of information on our website per program. And we are always available. If you go through the program, you go to the website, you have questions, our contact information is on the website. Please feel free to reach out if you have any questions. So again, in the interest of time, we're going to hold questions to the end. If you have something burning, please write it down and we'll be happy to answer it at the end. So it's my pleasure now to introduce Professor Dr. Hal Sorensen to talk about the AESE program.
Okay, I just was unmuted. Can everybody hear me?
We can. You're good.
Okay, then we'll get on with this thing. I want to talk in my mind, the architecture-based enterprise systems engineering leadership program is probably different than you're going to find most any place. As background, before I get into the details, just to give you some context for the program, it's not a systems engineering program in the classic sense. It really is a systems thinking program, and this came out of the experience that I got when I was a senior vice president general manager at the MITRE Corporation in Bedford, Massachusetts, in charge of Air Force C2 systems, where we did all of the systems engineering for the Air Force in building command and control, communication, computer intelligence, reconnaissance, and surveillance systems. And it was a big staff. We had a couple thousand engineers working, doing systems engineering. And it was lots of different projects, many projects. In the kind of the 62, 63, 64 timeframe, I'm not sure when it was exactly. I started in '89, so this is a long time ago. I was called to a meeting, asked to a meeting with the Assistant Secretary of the Air Force's Acquisition, a man named Jack Welch, and the three-star general commanding Electronic Systems Center, Gordy Fornell, in which they basically told me that the MITRE's role was going to change with the Air Force, that they were not going to do many new project starts. They had plenty. What they wanted to have MITRE do is become the one who integrates existing systems, makes them interoperate, and gives capabilities that exceeded anything they could do before. And we started off with something called the Cheyenne Mountain Upgrade Program. It was an interesting experience for me in the sense that over the next 6 years or so, 8 years before I got too old to stay and had to come back to UCSD, I had a very difficult time getting the Air Force project managers to ever worry about integration and interoperation. And so everything remained very stovepipe, classic word. And I had my systems engineers continue to kind of their stovepipe version of that. And by the time I left, I was convinced that what was needed was a picture of a broader view. And that's where we get into the enterprise. And so it's not systems engineering, it's enterprise systems for this program. And we've started that. When I got back, I talked with the new dean. He asked me to start this program like this. And that's what we've been doing now for quite a long time. First pilot program was in 2006, and we have been offering master's degrees since 2010 with it's approaching 400 graduates so far in the program. So what we're doing is I'll describe very briefly, and then we could talk about it in the out session as we get there. I'm the faculty director, founding director, and John Wade, who's joined the program, joined the UCSD a year ago, is co-director for the program, and his job is to support this program, but also he's developing a a master's degree program for continuing graduate students. It would be a classic Master of Science program and go in the fifth year, be done in the fifth year of a 4+1 kind of a schedule. So John plays a role. He's already lectured this year, and we're moving right along. This program is intended to be directed toward people who have several years of experience. 5 years is what we nominally say. All these are just guidelines, though I have to admit, and I'll repeat again later, is we've had students who started with as little as barely 2 years of work experience who did very well, but they had a different perspective when we admitted to the program. So the 5 years is desired, but it doesn't necessarily mean it has to be there. We also will drive that, as Philip has said, the program is this 8 hours a day, 2 days, Friday, Saturdays, every other week. We also have a 4-day workshop in the middle of that. So the 4-day workshop goes Wednesday through Saturday for 8 hours a day, and everybody's consistently pretty tired there. Next chart. Okay, hit the first button. Now, our architecture-based enterprise systems engineering program has 3 major things. The enterprise is the little diagram on the left. It says we start by looking at the ecosystem or the environmental, the environment or whatever you want to say, the real world, where the program is going to be working, with some attention paid then to sponsors and that sort of thing. We pay a lot of attention and ask teams to get stakeholders to work with their projects as they go. And that is kind of the top down in. We use that to develop the vision for what we're trying to accomplish, the problem we're going to solve, and put that then in terms of a strategy for accomplishing that, build an infrastructure, talk about the information systems primarily, and carry that down to the details of individual systems. That's the enterprise part of this team. The second chart in the middle is basically the systems that we're doing. This could, if we took all the arrows out except straight down, we get a waterfall, and that's the classic systems engineering program. Here we have feedback between all the blocks in ways where you can't predict, and that's because our systems are all networked together and are not very amenable to analysis at all. And so we basically don't bother with much analysis. And then the architecture is driven by the diagram on the right, which is really the kind of the block diagram description of the unified modeling language. We talk about UML and SysML and a variety of other things. Next chart, next button. Unlike the other programs, this from the beginning has been a joint program between the Jacobs School of Engineering, clearly, and the program is housed in the Jacobs School. So you get an engineering degree when people graduate, but half the courses are basically based on the Rady School of Management. Our classes, not this year because we've been on pandemic all the time, our classes in the past have always been over at the Rady School, and we meet over there on our Friday, Saturdays, and our Wednesday through Saturdays sessions. So that's what it is. Next chart. I pause that because engineering is not the emphasis. What we're really talking about is systems thinking and leadership. Because one of the things that I discovered, at MITRE was that I think engineers are the knowledgeable ones, that they should be leading lots and lots of these integration, interoperation sorts of programs. And so that's what we emphasize as we go through the program. Now, as I said, the program is concerned with integration and making of systems and making them interoperate in ways to do things we couldn't do before. We have lots and lots of different topics and things that are all built around all these things that say how we make stuff go together. And that is what we've called a system of systems, is putting all these things together. So next chart, please. And Philip, I didn't check my watch when I started, so tell me how much time I've got as I near the end.
Will do.
Next chart. Now, the program basically is broken into 3 major parts. In the fall quarter, we really emphasize the overall ideas of system thinking. Okay, and systems thinking deals with leadership, setting goals, identifying visions, defining projects, and the strategy for solving them. And then we add to that, unlike most engineering programs, emphasis on finance and accounting, and break that down into complex systems, which are these network-based systems, and then talk about the way to develop and our things is to use agile development and use development operations sorts of things. Starting in the fall is the team project. Everybody who joins the program in September, October 1st, whenever it starts, will become a member of a team, and that team is going to start from the beginning to define a project, and that project will have project assignments through each of the 3 classes in the fall quarter, and people will have then at the end of the quarter a team project start, which is based on 3 elements which go into the strategy, the elements, the finance, and then how we do DevOps. Next chart, next slide. In the winter quarter, and we add, there we go. In the winter quarter, we focus, and it's the most technical part of the program, we focus on enterprise architecting and architecture frameworks and move that into reality by defining what we're trying to operationally achieve, what is our operational concept, what are the capabilities required to do that, and then what are the use cases that we can use to describe those capabilities. Those use cases are used then to do domain modeling, which is where we start to build the architecture for the system. We supplement all of that we end that by talking about service-oriented architecture so that everything is loosely coupled, so we have lots of flexibility in the way we build our systems. We supplement that by talking about how you govern such systems. And Ken Griesi talked about that in the winter quarter, and he'll return to it in the spring. We'll talk about cybersecurity as something that has to be built in from the start, not tacked on at the end. And then we complete the question by talking about physical and functional architectures, and end the winter quarter on that base. In the next quarter, in the spring quarter, we move on. Next slide. And we talk about measures of performance and effectiveness and try to evaluate how good a job we did during the winter quarter, and then move that on to talk about event-driven architectures and use that to drive the way that we implement decision-making schemes and implement and talk about the art of decision-making. We go into more detail with Thomas Romer on data and analytics, and then close that out by talking about big systems, large data, and deep learning, machine learning sorts of things. The quarter, we do talk more about investment valuations and net option values, and then close by talking about how you're going to work the end of your program by building your team project into something which is going to be presented at the end of August. We don't have more classes in until the last week of August as does that. We do lots of tools. This is just an indication of some of the tools that students will get and use. Okay, so that's what we study in the program. Systems thinking, which gets us started. Architecting, which means what we mean, and then how that ties to making decisions in the spring quarter. Next chart. Next. Okay. Our model for the program, and you should be aware of it, because if you don't like that, then there's probably a good reason not to take it. But we use what is called in the literature the 70-20-10 model, which says we think that you're going to learn about 10% of what you carry away from the program due to the lectures that go throughout the program. We supplement each course that has lots of breakouts and team project sessions where our students are mentored and start to talk about how they're going to be coached, and they learn a lot, and that adds 20% to what they're going to learn for the year. And then they get to the end to do on the job experience, which is their team project, which is what they do then, and is an emphasis throughout the entire course of the program. Okay. Now that says in the development model, next click, that we'll start in the fall by defining the program, the problem that somebody's going to do. You'll start talking about that in the very first class. As we go through the fall quarter in the second and the next two, you'll next click, please. We'll define the capabilities for the program, and then you'll spend the entire rest of the year. Next one, please. Basically talking about how you're going to develop that through your team project models. And that basically starts and is built around the development of an architecture. So that's what we do. We have lots of lectures, we have lots of mentoring, and we have lots of team project things. Now, so what we're going to talk about is work our way through enterprise landscaping, enterprise stakeholders, defining that. We want you to talk to your senior managers as well as your colleagues. We then want to go on and talk about our capabilities, look at different alternatives to achieve the capabilities, make sure we create business models and use cases so we can develop the architectural models and verify their logic as we go. Next click, please. So this is a very brief summary of the earlier chart of what we do in AESE. And so this is the emphasis. And you should walk away from here being able, hopefully, to lead the development of these integrated systems. This is nothing new. And so this is kind of, we can probably skip past this very quickly. It's a one-year program, unlike the other programs, which are 2 years. The feedback I've gotten has consistently supported the idea of doing this in 1 year. I want to do it for a year because I think I don't want people to forget what they learned in the fall by making it the fall before last. So we get this done in a year, and people work very hard, but I think they come away with a very positive statement out of what they've done. We told you the hours, 8 to 5, primarily Fridays, 3 courses, academic quarters a quarter. We have a team project meeting at the end of every quarter where you talk about team project, and that forms the basis for the things that we do during the team project work at the end of August. Next chart. Nothing here. This is not very accurate in the sense the programs in the mechanical and aerospace engineering programs, we let people in from other departments, but beyond just computer science and electrical and mathematics, we let people in who have no degrees in any of these things, depending on what they've done. One of the best students we've ever had at the time worked for Northrop Grumman. He had a bachelor's degree in music from SUNY Buffalo, and he was one of the best project managers that we ever had in the program. So depends on what you've been doing, whether or not you're qualified. Certainly at the heart of it is having an engineering background. The academic affairs requires a
Now I think you're frozen, Al. We're having some technical difficulties here. So we've lost you, Hal. So to finish up the pieces that he had, that we want a statement of purpose. We really want to know why you believe this program is a good match for you and how it fits with your career objectives. We'd like the three letters of recommendation, and typically at least 1 or 2 of those should be by somebody who is a manager who can really attest to your potential. As he said, typically 5 years of relevant work experience. If you've got really strong relevant degree and work experience that's less than 5, by all means, feel free to apply to the program. And if you have at least 2 years of experience, we do not require the GRE. And come on. So that is the AESE program. And again, please hold your questions. And when we get to the breakout room, you can ask away with all sorts of questions about the AESE program. It is now my pleasure to introduce Dr. Ryan Kastner to talk about the wireless embedded systems. Are you here, Ryan?
Yes. Hello, Philip. Can you hear me all right?
I can. You're on.
Excellent. All right. Thank you. It's nice to see all you smiling virtual faces in front of me in my bedroom downstairs in my house. But we will soon be back on campus according to our plans, hopefully in fall. looks like. So I'm here to talk a bit about the Wireless Embedded Systems program. This is a program we've been running for almost a decade. And this is a joint program between the Computer Science and Engineering Department, where I'm a professor, and the Electrical and Computer Engineering Department, where my co-director, Fred Harris, is a professor. It's really trying to combine the greatest things of both departments and give you a unique experience of understanding how to build wireless embedded systems, very focused on that aspect, of course. So our audience, our typical students, are people that have been working in industry for some bit of time, ranging anywhere from a couple years to decades. Typically, those people have an undergrad degree in either computer science or electrical engineering. And so they're looking to expand their knowledge in one or the other, or just refresh and understand some of these burgeoning topics in wireless embedded systems. So as Philip mentioned, it's a 2-year program, alternating Fridays and Saturdays, and a little bit under 2 years, 7 quarters. So starting in the fall, and we go pretty much continuously fall through summer, and then we end in the following spring. And I'll talk a bit more about that later. Next slide, please. So why would you want to do this? What kind of people are taking this program? So the kinds of things that the students learn about in this program, and the kinds of things that they go on to develop in their companies after they graduate from this program, are related to a couple big buzzwords. So the Internet of Things is definitely a big buzzword that has been around for probably a decade now, or maybe even more. But the idea there is that everything is going to be connected to the internet. So my washing machine often tells me that I need to clean it, and tells me how many cycles have been messed up because I connected it to the internet, which may or may not be a smart thing in terms of security, but it's a useful thing occasionally to let me know what's going on. 5G is the next generation of wireless, and so if you have a newer phone, it's probably popped up in the corner of your screen there, and that is promising to be higher throughputs, lower latencies. So a lot of things that are going on there, a lot of infrastructure building around 5G right now. And of course, Qualcomm, our local our friend, is developing a lot of the technological efforts behind that. So kind of combining those two types of things is what we try to teach in this program. So how do you build embedded systems, small, tiny little systems with sensors and actuators that can do a variety of things, ranging from robotics to agricultural sensors, to drones, to wireless devices to track your dogs, and all kinds of different things. And then using the more advanced wireless communication infrastructures and learning how those actually work. So learning what is going on in 5G or 6G, so on and so forth. So it's a combination of that. So you can kind of understand sort of the IoT stuff comes more or less more from the CS side, while the 5G comes from the ECE side of things. So it's a very interdisciplinary, multidisciplinary project, our program, that you get exposure to both professors in computer science and electrical engineering. Next slide, please, Phil. Okay, so to kind of better articulate what we're going to teach, and you can probably just pull this whole slide out, Philip, for me, so I don't keep telling you to do next, is that we have a number of courses, and those courses come from kind of traditionally from both one side, from the computer science side, and also from the electrical engineering side. So on the left there, the computer science side, we have classes about embedded systems where you learn to use Raspberry Pis and FPGAs and GPUs, and but also all embedded types of things, right? So building robots, building medical devices, these sort of applications. How would you hook sensors up to these devices? How would you compute in low power on these things? And we have classes on how to program them, so doing the software, and also doing the hardware. So a lot of embedded systems these days are building hardware design. So there are more and more companies that are building up their own ASICs, building up their own custom chips in order to get lower power, lower cost. On the electrical engineering side, on the right, we delve into very traditional topics that is taught in most undergraduate electrical engineering degrees. The DSP, so digital signal processing, how does that work? How do you filter signals? What are signals? All kinds of very fundamental and basic ideas there. And then building on that, how do you develop those into communication systems, wireless communication systems? So how do you take those signals all the way up into systems that can send basically tiny little signals out into the air, and you can receive those in a ton of noise and decode pretty reliably what is happening. So probably most of us, amazingly, right now are using wireless communication in order to listen to me ramble on about these topics. So pretty impressive stuff. So in this program, you would learn, get an understanding of how all of that works. Throughout the program, we have very specialized and very kind of projects focused classes. So in all of the classes, you are typically using the latest and greatest in both software and hardware. So we're very excited to get back in person. We've done, I think, a fantastic job of doing things out of person remotely, but we're excited to get back in person so that we can have our students back in the labs and using all of these just sort of latest computational devices from NVIDIA, from Xilinx, from Intel, and all kinds of different sort of wireless radios and systems that are emerging, and the software to develop that. So all of the classes have a very project focused aspect to them. And then this is culminated in your final quarter, which is going on right now. And actually, I'm happy to invite all of you later on in June. We'll have a capstone presentation for the current class. So if you're interested in understanding what they're doing, that would be something I would be happy to invite you to. I'm guessing it's going to be virtual again. But the capstone is basically a culmination of all of the things you learn, and you get to kind of propose what you want to do and demonstrate the knowledge that you've gotten over the course of this program. So it's a lot of fun, a lot of system building. Like I said, that's the kind of stuff that I really enjoy doing. Next slide, please, Philip. So this is laid out, basically the same information, but laid out more sequentially in time. So the key points here are that we start out slowly. So we start out giving you only one class at a time. And that allows you to kind of get back into the flow of academics and studying and figuring out your schedule, because it is a lot of work. It is a real master's degree, and to do that and get a real master's degree from a top engineering school requires a lot of work. So what we try to do is to try to make that as easy as possible on you. So we spin that out one at a time. And the other thing you'll notice here is that we have a mix of the electrical engineering. So kind of the fall year, first year one, DSP is electrical engineering. And then we hit you with the computer science side of things, and then back to the electrical engineering, back to computer science. And then in year two, you start with two classes, at least for the first part of it. These two classes are one from computer science and one from electrical engineering, but they're carefully orchestrated to make sure that they fit together and that we're not overwhelming you too much. And then finally, in the spring quarter, you get to your capstone project. Next slide, please, Phil. So we talked a lot about this, but we're very open to people that we will think will be successful. And being successful, we've seen in the past, means a lot of different types of things. So definitely have a dialogue with us if you are interested or trying to understand if you will or will not be able to be successful in this program. So we can talk more about this, I think, in the breakout session, because it is a very unique, and all these programs are very unique in the terms of the types of people that they educate. And so we try to be very open and in that regard. Next slide, I think, is questions. So I will be in the breakout room and happy to answer all of your questions then.
Thank you, Professor Kastner. And our last program is the data science and engineering. And actually, I don't know if which professor is going to talk about
I'll be presenting today.
Wonderful. A pleasure to introduce Dr. Ilke Altiknits, please.
Hi, everyone. Nice to have you here. And I'm presenting the Data Science and Engineering program for me and Professor Alim Doic, who is also here. So the intended audience for our program is definitely anybody interested in data analysis, the way I would view this as, and your background in computer science or other engineering or mathematical domains would help. But if you have related work experience, definitely that would be included as well. So we are looking for really with some substantial experience in data analysis. And the program is a 2-year program, like you heard from other programs as well. There will be a lot of repetitions here that I'll refer back. And the cohort that we are accepting applications for starts in September 2021 and ends in June 2023 with a capstone presentation, as I'll explain. And typical of these MAS programs, it has classes alternating Fridays and Saturdays. Every other week, you'll be here for the classes Fridays and Saturdays. So as you heard, we did a lot of things online this year. We are hoping to be back on campus, but there was an online component this year as well. Next, please. So why are we talking about data science? We are talking about it because the data is getting bigger. If you heard of big data, what does that mean? It means data coming from anywhere and anything, and mainly through the internet. And this type of data has some challenges. You'll see the data grow as I speak here, but typically defined by its V's, for instance, volume, variety, veracity, velocity. But the best V in there is the value. The goal is if you can handle some challenges related to these V's and get some, data science working for you, you'll get a lot of value out of data. And these volumes have challenges, the V's have challenges, right? Typically, volume is the challenge related to the size. Variety is the challenge related to complexity of data coming from different environments in different shapes and sizes. Velocity is the speed. Think of Twitter. One day you might have a little bit of tweets, and then there's a presidential debate. You might have 100 times as many. So that's the type of velocity, and it flows, so to say, faster. And then when you have data from such different sources, you also typically have quality issues related to that. So you need to understand its veracity. But if you could get around this and use data science, you could really turn data into a valuable entity that has some domain-specific things in it. You can use it in different applications. So you're generating what we say insights from it. So the data science activity is to take this type of data to generate insights from it. I believe there's one more. If you could say next, I think there will be one more bubble there. So some of these bytes I can't even pronounce, but the idea is 1 minute of the internet generates many forms of data. And we are almost creating this universe of data. And there are some tools that we can use under our sleeves as data scientists to be able to analyze and turn data into value. Next. What are those tools? Typically, it's a combination of some programming skills, math and statistics knowledge, so some skills in math and statistics, and domain expertise. So hacking skills include being able to actually work with data to manage it and engineer it in a way that we can take advantage of it. And we hear a lot of these cartoons, our data scientist unicorns. Can anyone have this much experience together? Knowing the breadth of these is indeed required. You need to understand the breadth of the activity, even if you're going deeper into one of these areas. to solve a problem using data science as a team even. Unicorn is the team, actually, not the individual person in that context. You need to understand still the breadth of this activity, and the program is designed to give you the fundamental skills and related tools to start your data science journey with some ways to be able to extend it later. So it's a good combination of both theoretical and applied methods and tools. Next, please. And this spans a 2-year timeline. As you've seen in the other programs, the design is actually quite similar. In the first year, we are going to introduce Python as the language we'll be using for most of the classes, although there are some other variations that you'll be learning along the way. But Python-based data analysis is what we use, and it's becoming almost standard language for data science. Of course, there are some others like R, MATLAB, and other languages that are being used as well. So we start easy, so to say, with the Python course, and what you're seeing here as DSC 290 is a 2-unit course that's a seminar class that spans through the full 2 years. And what you're seeing in these seminars are, as the name suggests, case studies, both in the industry and academic context that involve data science. So by the end of the program, the idea is you'll be able to see a variety of applications and domains that data science is being used. And you'll hear from the industry and academic experts what they are doing with data science and what their job involves. And you'll be able to meet with them if you're in person and have lunch with them. So we have great lunches, by the way. So the main thing here is we also have some of our graduates these days from the alumni from the previous cohorts join us. So you also get to meet and network with them. The winter quarter in the first year will introduce you data management systems and probability and statistics. And now you're seeing the Python influence some of these courses using Python. And then we're going to move on from this more fundamental skills to machine learning and scalable data science using Hadoop, Spark, and other big data tools. In the second year, we'll extend this skill set with data integration and ETL. Extract, transform, load stands for ETL. So basically being able to get real data or raw data and turn that into something we can work with. And what you're seeing is 2 courses. One is the Beyond Relational Data Models course and Data Visualization course. These are sort of the electives, but these are the only ones. So this is the class you'll be having. And they might be subject to change based on, how the program evolves. But this has been pretty consistent, and I think this is what we expect for this cohort as well. And the orange one is the fun one, and I might be biased, I'm joking, because I coordinate the capstone courses and teach some of the applications of all the classes into problem solving. But it's also a class that's designed to bring it all together for you. We would like you to finish the program with a problem, real world problem with raw data, not test or teaching level data sets, but real data from the world as it relates to application areas in science and society and engineering. We had many different ones I can explain in just a sec. But this is a 2-quarter capstone project that groups of 3 to 5 are expected to work together to deliver a data science solution and a product. So it also includes a data product development by the end of the 2 quarters. so far, the capstone projects we've had related to many different applications, including scientific domains like biology, microbiology, protein analysis like enzymes this year, or fire science and things like that, but also industry-based projects, including Amazon and recommender systems, and Twitter analysis, and many different projects related to things that extend what you learned in the program with new sort of skills to solve this challenge. So typically you get an advisor, faculty advisor, and a domain advisor for these projects, and they are really designed to use every skill you use in the program and you learned in the program. Next, please. Admission requirements are actually pretty similar to the other admission requirements. You're still expected to submit your recommendation letters and everything that you've seen listed in terms of your transcripts and your letters, your purpose statement. But how we really evaluate based on those is we look at 5 skills for the admission. Major ones that we look at are programming experience, maybe not in Python, but in another programming language, in a way that you can actually learn something really fast. Like if you haven't coded in Python, but if you use another programming language, it's going to be easier for you to pick up and learn in the program. Experience with databases, especially relational databases and querying, and experience with data analysis in an application domain. So this might include your job, it might include your prior studies. These are really important because it shows the analytical skills required for you to be successful in the program. And we'll ask you actually in the admission form questions related to your experience related to these areas. And we would expect you to really describe in plain English what you have as experience that relates to them. And then we also look at some other skills. Especially admissions are a ranking process, and definitely we look across the board. But some skills in statistics and math, like linear algebra and probability and things like that, really help. It strengthens your application, and it also helps you to get through the program easier. So if you don't know, I would suggest taking some online classes and bridging the gap. So the program will be a lot easier for you to go through, and some experience of distributed systems. And we understand this is a skill that not everybody gets a chance to apply in their work, but some experience with them typically help. And the program will, of course, build on those skills and give you skills to go beyond what you already know. But if you don't have experience in at least 2-3 of those areas, typically your applications will not be considered strong. So I would like to really emphasize that these are important requirements that we look at, and it's to ensure success in the program and to make sure you're spending your time in a valuable way here. So Alvin and I will be in the breakout room to answer your questions. Thank you for listening.
Thank you, Dr. Tintas. All right, so next steps. Go to our website. There's a lot of information there. Any questions that aren't answered on the website, please feel free to reach out to us, and we're happy to work with you to get your questions answered. So now we're going to turn off the recording, and we're going to open up